Welcome to the poster voiceover video for the UNCC FSAE electric vehicle for Senior Design 2. The objective of this senior design team is to redesign, simulate, and manufacture a battery cell cooling system and manufacture the Energous replica. We're going to finish the drivetrain design and single rear brake design along with finalizing suspension design. Our deliverables are obviously creating a battery cell system that can be tested and simulated, have finalized the drivetrain design, and reduce weight and fixed suspension design issues. For the suspension, general parameters are double wishbone pushrod, wheelbase is 16.5 inches, track width of 46, 0.97 inch of 2.1 inch front and rear roll centers, 10% rear anti-squat, and -1 degree of static camber both front and rear. Tires we're using are Hoosier R20Bs on a 7-inch wide TJ forged rim. The rear toe change initially was far too great. It was plus or minus 2.5 degrees per inch instead of the desired maximum of 0.1 degree. With a whole complete redesign is now only 0.03 degrees per inch. For the drivetrain, we'll be using a MRX 228 electric motor as seen in Figure 4 and a Drexler SAE differential as seen in Figure 5. We'll be having a maximum output of 62 kilowatts. The FSAE single or Drexler differential will have a modified single rear disc brake, which will provide for regenerative braking and an easy solution to our braking issues. Testing goals for the battery cooling system are that we're going to assess the heat generation of the batteries, verify the electrical performance of the batteries, determine optimal coolant flow rate through the batteries, and verify the fit and assembly of the connection of the battery module. We'll be using 6 18650 cells on 3D printed materials, and we're going to have aluminum heat sinks that provide coolant flow. The testing enclosure will have 3 18656 battery modules. Testing output is 12 volts at 180 amps. Integrated temperature sensors, 4 heat sinks in an enclosed aluminum container. The temp sensor consists of our Arduino microcontroller, 10K ohm thermistors, and 10K ohm resistors. Monitors the temperature of the cells by using the thermistor to change resistance into a temperature. In the top right, we have the coolant flow diagram, which is an accurate representation of how the cooling will be operated. Then below that, you have a diagram of the low, medium, and high voltage setups. The testing plan, we're going to be using 3 different battery chemistries, 5 varying load cases, along with 4 different coolant flow rates. We want to be at 60 degrees Celsius. That is one of the cutoff points. The batteries will be loaded using vehicle headlight bulbs, and we'll be using deionized water for coolant. As you can see in the bottom image on the bottom right, that is our battery loading setup.